Hello, in this brief lecture, I'd like to discuss some basic concepts in statistics. Also, I'm going to discuss notions such as variables, measurement of variables, display of variables, so on and so forth. So this is the introduction to statistics in geography. Statistics is a set of techniques, concepts, and principles that we use to organize, display, and interpret data. The goals of statistics are several-fold. First, we use statistics to describe and summarize a body of information or data. For example, we can calculate the average grades of a class to give a sense of, for the entire class, what is the general level of performance. We can also use statistics to study a statistical population's performance. For example, if we want to know the housing value of an entire county, instead of go out there to collect information of every single house in the county, we can collect a sample of houses from the county, such as we can collect information of 300 houses in a county, and to calculate average home value of these 300 houses. And if we do it right, the average housing value of these 300 houses may be pretty close to the average housing value of the entire county. In addition, we can study the relationship between variables. For example, we can study how the increase in temperature may help increase the precipitation by using the correlation or regression techniques, which we're going to study later on in the course. In geography, we use quantitative techniques to conduct geographical analysis. For example, we can study the income level differences that exist between the central city and the suburbs. We can also study what we call the urban heat island that exists in big cities such as St. Louis. So the quantitative techniques in geography has become an important aspect in the study of geography. That's why it has become a required course in geography major. In study statistics, we use basic data, and the data could be numerical information, but could also be non-numerical information. We normally organize data in a data set, put them in a kind of structure such as a spreadsheet. And here is an example of a spreadsheet that we use to organize data. And we measure data in basic units that we call observation or cases. In this example, the basic measurement unit of data is a country. For the last example, the basic unit we use to measure data is the state. We can also use counties and cities or individuals as a basic unit of a data measurement. And within the data set, we have variables. These refer to a set of attributes or characteristics of a different unit of measurement. And one variable measures a particular attribute or particular characteristic of observations. In these examples, we have variables such as country names, average income, percent of male at work, and so on, so forth. For a variable, we have variable names, Also the actual data value. It could be the numerical value, but also could be the non-numerical value, such as the names of countries or state. Those numerical values could be a result of measurement, or it could be the result of calculation. And here are some concepts relate we have used before: statistical population, or population in short. These refer to the entire group of entities that is under investigation, and that can be people, objects, or events. Okay. In terms of people, if we want to study the average age of the U.S. population, here the population would be all the people in the country. If we want to study the housing value, and then in a county, then all the houses as object within the county will be the statistical population. Of we want to study all the elections that occurred in a state in 2013. These events will become the statistical population. But sometimes, a lot of times, it's very time consuming or expensive to study a statistical population. Instead, we go out there to take a subset of the population we call the sample, and we can study the performance of this sample. And if we take this sample really representative, the characteristics of this sample may be very resemble to that of the statistical population. And the study sample is very quick and very less time consuming, less expensive. That's why we study sample. And using sample as a representative of the population is one of the most important aspects of statistics. And in inferential statistics, we are going to study how we use a sample mean to infer information about the population mean. Now let's look at some of the issues related to variables, types of variables. There are different types of variables. On this slide, we can see the organization or classification of variables into qualitative variables, quantitative variables. And on the quantitative variables, we also have discrete variables and the continuous variables. Now let's take at each one of them in terms. Qualitative variables refer to variables that are measured in kind, that they are different in kind, different names, different colors of eyes, different colors of clothes, different gender, and these are all examples of qualitative variables. And qualitative variables is also called categorical variables. Then in contrast, we have quantitative variables. A quantitative variable can tell us observations how they are different in amount, okay, and different level of income, and different age, and different body weight, different body height, and different temperature between places. So these are all examples of quantitative variables. And under quantitative variables, there's a difference between discrete variables and continuous variables. A discrete variable is a variable that can only take certain values, such as integers. You look at the number of people, it always comes in whole number. You don't have half a person. So most of the times, the discrete variable, the value comes as a result of counting. You count how many people are in the room, how many animals are there in a farm, how many houses in a community, you count them. So this is discrete variables, the values always the result of counting. Then we have continuous variables. A continuous variable can take an infinitely large number of possible values. You can take 1.7, 1.71, you can take 1.752969. So a, uh, a, a sign of a continuous variable is that a continuous variable can take decimal places. You have you can, if you want to increase the level of precision, you can take many decimal places. That's one of the reasons why you have such a large number of possible values for continuous variables. And the continuous variables a lot of times is a result of a measurement or calculation. You can use a ruler to measure the size of a table, and depending upon the device of measurement, also depending upon the level of care, you can really go into higher level of precision. Instead of you can measure the width of a table size is 3 inches, or the or 3 feet, or 3 feet 5 inches, or 3 feet 5 inches 9.5. You can really increase the number of decimal places infinitely, and to give a higher level of precision. So the continuous variable works very differently than the discrete variable. It's a discrete variable most of the times is a result of counting. In contrast, continuous variable comes as a result of measurement or calculation. If you calculate the average number of children of a household, you use the total number of children in a community divided by the total number of households, and you come up with 3.59. So you have this decimals in the result, and obviously that's not result of counting, that's result of calculation. A lot of times percentage is also the result of calculation. 3.5%, 3.59317%. So that calculation can go into very high level of precision. So in addition to different types of variables, you also have so-called scales of variable measurement, and nominal scale measurement refer to the variables that you can put them into different categories of different classes. Male, female is an example of a nominal variable. People's names is also example of nominal scale of measurement. The different countries, different occupations, and different colors. These are all things that are different kinds of things. Okay? You don't really get a sense of how between different categories, how they compare in terms of importance, in terms of ordering. There's no sense of ordering, there's no sense of which is more important. Okay, so that the different kind of things that basically is the nominal scale of measurement. Then you have ordinal scale of measurement. In this kind of variables, you get a sense of the ordering, and many times in some kind of a survey, you are required to give ratings such as like it very much, like it okay, do not like it very much, do not like it extremely. So those are sense of give you a sense of ordering, or the income level can below 10,000 and between 10,000 30,000, and from 30,000 to 50,000 and above 50,000, again give you a level of ranking. So that's an age differences as well. Younger age, middle age, older age is also a give you a sense of ordering. Now I'd like to discuss the interval scale and the ratio scale together. Both interval scales and ratio scales involve numerical values, and they can tell you between different observations how much they are different from each other. For example, a place with the average temperature 60 degrees compared with another place the 15 degree, you can really get a sense of the difference in temperature between the places is by 45 degree. Same way for ratio scale of measurement, one person make $10 per hour, the other person make $20 per hour. You can get a sense of the difference between the two is $10. So the interval scale and the ratio scale both involve the numerical values. You can really tell things apart by telling how much they are different from each other. Okay, but between the interval scales and the ratio scale, there is a significant difference here. This difference can be explained by this looking at the nature of zero. If I said that I don't have money, that means I don't have money. So I have $0. That means I do not have any money. So in this case, zero means the absence of the attribute of this variable. The variable is income. If you do not have income, if your income is zero, that means that you have a true absence of this attribute income. So if that's the case, this variable has a ratio scale of measurement. Now let's look at another example, the latitude. If I say that for this place, the latitude is 0 degree, what does it mean? Does that mean that this place has no latitude? It does not mean that, because we know on Earth's surface, every place has a latitude. Every place on Earth's surface has latitude. The fact that one place on the equator, the latitude is 0, does not mean that there's absence of latitude along the equator. There are still latitude. The latitude is 0. The latitude is 0. The fact that the latitude is 0 does not mean that along the equator there's no latitude. There is a latitude. The latitude is 0 degree. So there's no absence of latitude, and the latitude is simply 0. Another example, in the study of weather and climate, people use degree to measure direction. 0 degree measure the north, 90 degree measure the east, represent the east, 180 degree represent the south, so on and so forth. So if I said that the wind direction is 0, does that mean that the wind has no direction? No. The wind does have a direction. The direction is 0, which means the north. So you can really get a sense of this 0 in the case of latitude and 0 in the case of directions. 0 does not mean absence of attribute. 0 does not mean that there's no latitude. 0 does not mean that there's no direction. Okay, so 0 does not mean the absence of attribute such as latitude and direction. So if the answer is no, and therefore we know that this variable has a scale of had the interval scale of measurement. So between interval and the ratio scale of measurement, they're all involved numerical values. Things are all different in terms of quantity amount. But when you look at the nature of 0, you can really tell things apart. To the question that whether there's absence of the attributes described by the variable, if the answer is yes, then we have a ratio scale of measurement. If the answer is no, we have interval scale of measurement. So we discussed this conceptually. I suggest you go ahead and do the in-class activity. Number 2, that give you more practice.